Hey guys, what's up? What's going on? My name is Shanto, and I'm going to show you guys how to do the coin change problem today. This is problem 322 on Leetcode, and it's a really common problem that you'll see in tech interviews, and it tests a basic understanding of dynamic programming. So let's go over the problem and what it is. So essentially, you're given an array of coins, and I'll use this example 1 as my example. So you're given an array of coins. So you have an infinite amount of 1-cent coins, an infinite amount of 2-cent coins, and an infinite amount of 5-cent coins. Now, what do you do with these coins? Well, you have to make up a certain amount that's given to you. So if the amount is 11, that means you have to create 11 cents in any way possible out of your 1-cent coins, 2-cent coins, and 5-cent coins. And what we're trying to solve today is what is the fewest number of coins of these coins needed to make up this amount, 11, right? So we need to make 11 cents, and we need to make it out of 1-cent coins, 2-cent coins, and 5-cent coins. What is the fewest number of coins needed to make up this amount, given the fact that we have infinite number of each of these coins, right? So I have my iPad here, and I will show you guys sort of the idea of what we're doing on the iPad, and then I'll program it out on the Leetcode interface here. So we have to create an array with the number of slots that is equal to the amount here. So for example, if we're using this example 1 where there's an 11, we're going to create an array with 11 slots. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? So the reason we do this is because, well, actually, sorry, we actually need 12. We need one more because this first slot, sorry, I'll actually add that to the back. This slot here will be the 0th slot. So really, we're going to make an array of 12. So amount plus 1, right? So the purpose of each of these slots is to let you know if you were to, for example, need to make up 5 cents at any given point, how many coins would be needed to make up 5 cents? Well, if we look at this array here, we could tell, like as a human, we could tell that you only need 1 coin, right? So I would fill this in with 1, right? If I were to go to the 8th slot, for example, how many coins needed to fill up 8? Well, I'm a human. I'm looking at this. I could tell I can make up an 8 with a 5, a 2, and a 1. So that's a 3, right? I could also make it up with 8 ones, but the fewest that I can see here is a 5, 2, and a 1, so a 3, right? So that's what we're going to be doing with each of these slots. Of course, the way we're going to be doing this is we're going to iterate through this array, right? And then we're going to fill in each of these slots with the minimum amount of coins needed. Now, we're going to be doing a cool trick here where we're going to refer to other slots behind it. So this 8 here will refer to slots, like 5 and then like 3. And then that will help us figure out how many coins are actually needed to fill in this 8th slot. And you'll see how we do that in a few minutes. So the first thing that we have to do always is fill in this first slot 0 with 0. That's always going to be the case because if you need to make up 0 cents, you need 0 coins to do it, right? That makes sense. Intuitively, that makes sense to me. So the first thing we're going to do is create this array, right? So I'm going to say dynamic programming array is equal to a new array where there are the amount of cents needed plus 1, right, to make up for that 0th slot, plus 1. And we're going to fill this with, honestly, this could be like any arbitrary number that is invalid. So what we're going to do is we're going to fill it in with the amount plus 1, because that can never be the case. So amount plus 1, right? So now you can think of this array as having 12s in each slot. Cool. Coolio. All right, so then the next step is to fill in this first slot with a 0. Simple enough. dp array of 0 is equal to 0. Bada bing, bada boom, baby. Sweet. So this first setup is already done. What you see here on this iPad, we have this now in our code. Pretty cool. Pretty cool. So now what we're going to do is we're going to iterate through the array and fill in the appropriate values in each of these slots. So what I'm going to do is I'm going to take the range from 1, because the first value is already filled in. So I'm going to take the range from 1 all the way to the amount here. So I'll do that with 1 through amount dot each and do I. So this I is going to represent which slot we're currently in. Okay, nice. So now that we have our iteration running, what we're going to do, and this is where I'm going to tell you the general strategy of what we're doing. So let's go through 1 through 3, 4, 5 as an example. So in this case of the 1, right, we need to make 1 cent, right? And what are our options? Our options are 1, 2, and 5. I'll just keep this up here. So our options to make up 1 cent, we have the coins 1, 2, and 5. So first I'm going to check this coin. So I'm going to iterate through my options here and see if they validate this specific case. In this case, in this case, 1 cent here will properly fill up 1 cent. That's awesome. So what that means is we only needed 1 coin to make up 1 cent, right? 1 coin needed. That's awesome. Yay. Cool. But for the sake of algorithms, because this is how it works, let's check our next one. 2. Oh, well, 2 is bigger than 1, so that wouldn't really make sense. So we're going to not even bother checking. And then 5, that's also bigger than 1. We're not going to bother checking. So cool. I'm going to fill this slot in the array with 1, because I know that I can make 1 cent with 1 coin. That's the minimum number needed. Cool. So now let's move to... Just going to erase this real quick. Let's move to our second slot here, right? 12. Not 12. 2. We need to make up 2 cents. How are we going to do it with 1, 2, and 5? Well, let's iterate through our coins again, because that's what an algorithm does. It does the same thing over and over again for each slot in this array. So if we were to use 1, then 2 cents would come down to 1 cent. And this is where it's cool, because we already know how much it needs. We already know how many coins are needed to make 1 cent. We need 1. So it took 1 coin to get us to 1 cent. And then from 1 cent, we can refer to our first slot here, right? We can refer to this first slot to see how many coins are needed to make up that amount of cents. So 1 coin to get us down to 1 cent. And then we can see that that 1 cent slot is already filled with 1 coin. So then we know the rest of the way is 1 more coin. 1 more coin. Which, brings us to a total of 2 coins. So I'm going to erase this and then fill this in with 2. And now you're going to be like, yo, wait, I can definitely make that with fewer coins. Well, yeah, you're right. But our first iteration through the coins will bring us to 2. Now we're going to get to what you were thinking, right? If we go to our second iteration, that's the number 2. Then we'll see, okay, well, 2 is not greater than 2, so we can check this if it's a valid case, right? 2 minus 2 is 0. And that's exactly what we want, right? So that's actually only one coin needed. Cool. And that one coin needed is less than this 2 coins needed. So we're going to fill that in with 1. And then our final case here is 5, in which case we're not going to even check because it's greater than 2. So I think you get the idea, but let's just quickly go through a third example just to really solidify it. So now we're going to get to number 3, right? So now we're on our third slot. I mean, really fourth slot if you're counting the 0. But basically we need to see coins needed. Coins needed to make 3 cents. Right? So now we need to make up 3 cents. How are we going to do this? Well, we're going to iterate through our coins, just like how we did with every other example. 1. All right. So 3 minus 1 brings us to 2 cents. 2 cents are needed. Guess what? We already know the fewest number needed for 2 cents because that's what we did in the second slot here, right? So 2 cents. So to bring us to 2 cents, that was 1 coin. And then from 2 cents, we know the minimum needed is another 1 coin. That brings us to 2 coins. So we're going to fill this slot with a 2. Right? And then if we're going to go to 2, then 3 minus, and then what changes here is what we're subtracting. 2 is equal to 1 cent. And 1 cent also needs 1 coin. So that's 1 coin to get to 1 cent, and then 1 coin to complete out the 1 cent. So that's also 2 coins. So we're going to leave this as 2. And then the last option is 5, which is greater than 3. So we're not going to even bother. And so that's how we fill out this array all the way up to 11. So let's quickly program that. Let's code that out. So what did I mention? We're going to iterate through our array of coins for each slot. So this is going to each slot. And now we're going to do coins.each, right? Our array of coins here. Coins.each. Do coin. Now we're going to check if that coin is less than or equal to that slot, right? So remember when I was like, oh, well, we don't even need to check 5 because 5 is greater than that slot, right? 5 has been greater than 1, 2, and 3, so we don't even need to check it. Of course, you will have to check it once you get past 5 and above, but for now, we don't have to check it. So that is some conditional logic, right? If the coin is less than or equal to I being the number of cents we need to make at that slot, because that slot and the number of cents we need to make is the same. Right? So if it's less, then we're going to check. What are we going to check? We're going to check if the DP array at that slot, right? Or if 1 plus DP array at I minus coin, and I'll explain this in a second. This might be a little confusing. Which one of these is less? Whichever one is less, we're going to take the minimum of it, and we're going to set this slot now equal to it, right? So to explain this further, we have, this logic checking if DP array at I is that less than or equal to or bigger than 1 plus DP array at I minus coin. So if we were to take the example and look at it from that angle, DP array at I. So if we were at our first slot, DP array at I originally, right, is 12. Remember, these were all filled with 12. So dp array at I would be 12, right? 1 plus dp array at I minus coin. If we were at our example, this number 1 example, right? What is I minus coin? That would be 0, right? Because I is this first slot, and the coin that we're checking right now is this 1. So I minus coin is the 0th slot. 0th, I don't know why that's a Z, whatever. 0th slot. And the 0th slot is 0. 0th slot is 0. And then we're going to add 1 because it took 1 coin to get to that slot, right? So 0 plus 1 is 1. Come on. I know you could do that basic math. 0 plus 1 is 1. Yeah, you know that. Okay. Cool. So then that means we can fill in. I mean, I don't know. You tell me, is 1 or 12 greater? Or what is the minimum between 1 and 12? I would say it's 1. I don't know. That's just me. So that means we're going to fill in this slot here with 1, right? And we're not going to bother checking 2 and 5 because of our original statement if the coin is less than or equal to I. So that's how you actually go about filling in all the slots. And then at the very end, we're going to check the last slot, right? What is our 11 looking like? Because if it's 12, then that means you actually couldn't have made that amount with the coins that you have. And if it's not 12, then it's filled in with some number of coins, which is the minimum number of coins needed to get to that slot. So we're going to do dp array amount. So we're going to check, is that final, because this amount is 11, right? In the array, in the final slot of the array, is that less than the amount or is it greater than the amount? Because if it's greater than the amount, then that means it's this original value we filled it with, this invalid value, which means we have to return that, like, you couldn't have made that amount with the coins given, in which case it tells us to return -1. Like, it just says return -1 here. But if that's not the case, then we can just return whatever is in that final slot because we filled in, this logic fills in for every slot the number of coins, the minimum number of coins needed to fill in that slot. So to make 11 coins, to make this amount number, you just find within the array that slot and return that. I hope that made sense. I am new to this and, I don't know. I don't know what I'm doing. And I think that's evident, but hopefully I'll get better with time. I think I minced up some words like right there. But whatever. I hope it was helpful. This is from more of a beginner angle if you're starting to do these algo problems. I know people on YouTube already make videos on these algo problems, but sometimes they go kind of fast and they don't really explain with visuals along with the coding and everything. So I hope this was helpful. I took a long time to explain, but I think that will hopefully make you understand more, right? Understand the process better. All right, thanks guys, and take care. Oh, I forgot one thing. I should probably run the code and make sure that this works. So let's do that real quick. All right, accepted. Now let's submit it and see our runtime and etc. As you can see, I got it wrong before. I was trying some different stuff out. Cool. And this number will actually, it'll change depending on how the system feels like it, right? So that was 78%. Now it's 66%. I submitted too soon. Now we're at 80%, right? So, who fucking knows? Wow, I shouldn't curse. Sorry. Who knows? All right. Thanks, guys. Take care. Good night.